Good morning. We chose our operating system case study on Chimera. Our team members are Adam Corbin, Sati Pangdar, Michael Hughes, and Sam Hong. Chimera is a real-time operating system developed for advanced sensor-based control application systems such as robotics, process control, and intelligent manufacturing systems. Designed as a local operating system in conjunction with global operating system, executing on one or more single computers in VME bus-based systems. Support features such as real kernel with dynamic scheduling, error handling, user signal, interprocess communication, global shared memory, spin locks, priority, message passing, multiprocessor task control, and host workstation integration. Real-time operating systems subdivided into real-time kernel, multiprocessor support, file system, and programming environment. Chimera is an open architecture real-time hardware. A typical hardware consists of multiple general-purpose processor, possibly on multiple buses. Chimera implemented around VME bus. Chimera supports Motorola MC680X0 family of general-purpose processor due to their one-to-one mapping of hardware signals with VME bus signals. Chimera's software architecture is divided into two distinct parts: code that runs on real-time processing units and code that runs on host workstation. On each real-time processing unit, user tasks execute concurrently, communicating with each other through local shared memory and local semaphores. They also have direct access to local I/O devices and can communicate with each other processors using any of the IPC mechanisms available. Each real-time processing unit has a server task which constantly monitors the express mail. The express mail is used to initialize IPC services and provide access to extended file systems. All processes communicate via local shared memory, and semaphore facilities are available in the host global operating system. The host server provides similar functionality as the server on the real-time processing units. In addition, it can access the host file system directly, and it includes special primitives to support the console processes. The console processes provides the user interface with servers to download and execute programs on the real-time processing unit. Major functions of Chimera. Processor descriptor. Chimera includes execution status, schedule priority, timing constraints, and supervisor stack space. Used to determine the current state the process is in to keep system in an organized approach. Communication. Chimera uses port objects using port automation model, which means all the data needs to be always updated. Includes input, output, and resource ports for real-time communication. Threading. Each task in Chimera is considered a thread to the system since all tasks are independent. Synchronization techniques. One major goal in Chimera is to be completely autonomous, which allows any processes to run without waiting on others. To make this happen, all tasks have to be completely independent to each other, which will allow any process to execute at any moment necessary. Deadlocks. Synchronization uses a spin lock, which means when a task accesses the global table, it locks the processor to make sure the task does not get swapped while using the global resource, meaning using only one single global variable semaphore, it is not possible to have a deadlock. Memory management. Chimera does not provide any virtual memory, as a memory management and swapping overhead do not decrease the performance of the system, but it also causes a system to become unpredictable. Chimera provides its own version of MACOL family of routines that allocate physical memory. Schedulers algorithms. Chimera supports different types of scheduling, including fixed, dynamic, or even mixed priority settings. The default schedule on Chimera is maximum urgency first. Several different scheduling algorithms are built into Chimera. The kernel supports both fixed scheduling algorithms like rate, monolithic, and dynamic scheduling like minimum laxity first or earliest deadline first. For maximum urgency first, algorithm also allows the scheduler to detect 3 types of timing failures and call failure handler routines for tasks which fail to meet their deadlines. Input-output. If Chimera is started in no GUI mode without command script file input, a prompt will be supplied with the system shell for entering Chimera commands on standard input. Any of the registered file types can also be opened from within Chimera. The most general ways are file open local files, fetch by ID files to be fetched from databases and from the Chimera command line using command open, in I/O devices, sensors, and actuators. Chimera kernel adopts 2-level approach to developing and using device drivers to isolate the user from the details of special hardware. The first level drivers provide a hardware and independent interface to I/O devices such as serial ports, parallel ports, analog to digital converters. The second level device drivers are not required but highly recommended. They provide a standard hardware independent interface to the sensor and actuators which are connected to the system via I/O ports. Task. A task in Chimera is also known as a thread or lightweight process in other operating systems. A user program which is downloaded into the real-time processing unit consists of a single executable file. Task management. Chimera provides the kernel task management features typically to all real-time operating systems, including creating, suspending, restarting, preempting, and scheduling. Provides a different approach to handling task timing. Whereas real-time operating systems require the user to program timers, the Chimera kernel performs all timer programming automatically. Inter-task security. Typically, of all tasks running on a given real-time processing unit are designed to cooperate. There is no inter-task protection, allowing one task to access the address space of any other task. It eliminates a large amount of overhead incurred in performing system calls or their equivalents. Desirable for 2 reasons. 1. To prevent multiple users or independent processes from infringing on other processes in the system. And 2. To contain software errors within a faulting module for better control of error handling. The evaluation of design. Advantages. Provides the common feature of real-time operating system but also advanced features required for implementing advanced sensor-based control systems. It does this by trying to be very like Unix-like with the programming environment and file system. It has a global handling error system, but by making it part of the operating system, it gives the advantage of automatically detecting of system call and kernel errors, allowing exception handling code and main program code to be coded independently. Chimera handles this that do not meet deadlines by using a deadline failure handling mechanism, which allows exception handler to be automatically called when a task deadline is missed. Provides many tools which make it possible to quickly develop modular and reusable software. It's able to provide required functionality at the highest performance possible by sacrificing one traditional operating system features such as virtual memory and task security. No child-parent task thread relationship. Any task or thread can communicate and synchronize with any other through local shared memory, semaphores, and user signals. A wide range of scheduling algorithms allow for Chimera to be used in different applications without being restricted to the default scheduling algorithm, like many real-time operating systems. Isolates the user from the details of specialized hardware by using a two-level approach to device drivers. The first level is a hardware-independent interface with I/O devices. The second provides a standard hardware-independent interface to the sensors and actuators which are connected to the system via I/O ports. Most real-time operating systems only provide local semaphores. Chimera also provides a remote semaphore which allows tasks on multiple processes to be used semaphores, adding a layer of transparency between the user and the hardware by providing high-performance, real-time kernel, and a variety of IPC features. The hardware platform required to run Chimera consists of commercially available hardware and allows custom hardware to be easily integrated. Disadvantage: lacks some traditional operating system features such as virtual memory and task security in exchange for extra performance. These are the list of references, and this concludes the overview of our operating system case study, Chimera.